The basic building blocks of C++. In your basic building block of C++, you're always going to have what's known as a function main. All right. A function, basically, a function contains instructions that perform a particular task for the code that the coder needs to be done. They're instructions that perform a particular task. And a program is a function or a collection of those particular functions. In every function main that you'll write in C++, you'll have return 0. Return 0 at the very end, basically to end the program. Note, if you only have one function in your program, then it's going to be function main. In your programs, you'll also have what are known as preprocessor directives. Preprocessor directives basically are a collection of libraries that contain pre-written functions that you can call on. All right. Therefore, you don't have to write them. In order to access them, you have to include #include and then the header file name in your program. When you want to output something in your program, all right, there's something called cout. All right. Cout is a predefined identifier accessed through the header file, if you recall here, iostream. All right, this is where you're using your preprocessor directive. So you're going to cout an expression and or a manipulator. And a manipulator allows you to manipulate what it is that you're putting out the screen. Let's look at an example. So here I'm running Visual Studio C++. All right, and here is my preprocessor directive. I'm using #include iostream so that I can access the cout identifier. Using namespace standard here, for now, just include it in all your programs. We'll talk about what that is and how it works at a later time. Your text, if you're curious and you need to know now, read about it in your textbook. So here is our main function, and as you can see here, we just basically really have one function, int main, and within there, with the two parentheses, we have our brackets to start it and to end it. Okay, and then we say cout welcome to Hogwarts. This is our expression, and then we also have our manipulator here, endl, which basically gives us a new line, takes us to a new line, and here's our return 0. As for system pause, just include that in all your programs for now as we're learning how to program. What it does is when I compile this, it'll pause this. If you don't have system pause here, this will disappear and you won't see your output. All right, you'll have to press a command on your computer in order to get to it. But here I have welcome to Hogwarts. This is what I cout. Okay, and basically the endl, if I were to print out something else, it would take me to the next line. And I can press any key to continue to remove that prompt. There are three different types of data types. There is simple, structured, and pointed data types. In our course, we're going to cover simple and structured, but not pointers. And for now, we're just going to stick with simple data types. Out of the simple data types, there's the integral data type, floating point, and enumeration, which we'll learn all three. Integral data types are things, or data types are things without decimals. Okay? Without decimals. Floating point data types store data with decimals. The difference between float and double are float data types have precision up to about 6 to 7 significant digits versus a double having up to 15 significant digits. I mean 15 decimal places, in other words. In our class, we're just going to focus really on the double. Although traditional programmers definitely use the float for obvious purposes of saving memory, in our class, in our author actually talked about it was where the double is easier to use because we don't have to worry about conversions, and with the inexpensive equipment that we have today, it's just easier to use the double. Now, if you're programming on a sports watch or something like that where memory does matter, then the float does matter. And you'll see examples in our book, and I encourage you to look through them. But in our class, we're going to focus on double. And then there's also the enumeration data type, which is a user-defined data type. And we'll get a chance to use enumerate data types later on in future lessons. Now that you know the different data types that are out there, let's talk about variables. Okay, so if you have a computer, remember in RAM, remember from your intro class, or a prerequisite for this class would be competencies for intro. What we're doing is we're reserving space in RAM to hold the data for these specific type data types. All right, and what we're going to do is we're going to declare a variable and name it something known as its identifier, and then assign it a value, such as perhaps 1, or if it's a double, a 1.0. All right, we assign it a value by using the assignment operator, okay, which for non-tech people would be the equal sign. 1 equal sign, that's the assignment operator, which is different from 2 equal signs, which we'll talk about later. However, it's important to note that the variable assignment does not mean equals to. Okay, it's not equals to, it is assigned something. There's also something called constants, and that's not variable. All right, when you declare a constant, it must be initialized. You must give it a value once you declare it. That's not necessarily the case here with a variable. When you declare a variable, the data in here can change. It can change from 1 to 2 to 3, okay, to 4 to 5 to 6 if it's a int data type. If it's a constant, once it's initialized to one of these values here, it'll stay that value. Expressions. Expressions are basically, an expression is basically a combination of one or more constants, variables, operators, and functions. Expressions are basically a combination of one or more constants, variables, operators, and functions. There are That's an expression, just to provide an example. There are three different types. There's an integral, floating, and mix. An integral, like our data types, simply mean that that all the operands, these are operands, and this is the operator. All the operands are integers. And a floating expression, all the operands are floating points. And in a mix, you have one that's integral and one that's floating. When working in C++, there's also what's called casting, type conversion, etc., typecast. What happens here is that sometimes when we're in a mixed expression, you may not get the value that you want in your program. And if that's the case, you want to cast. And we do that by the command static cast, and then the data type that we want it to be, okay, on that particular expression. It works from right to left here. So the expression is evaluated first, and then it's casted to the data type that you asked for. An example here. You recall pound include IO stream using namespace standard. Here is our constant. All right, constant float miles to kilometers equals 1.60934. Where the purpose of this program is to translate stated miles to kilometers. Okay. Here's our main function here, int main. Here is our data type, or here's our declaration of a data type int, which is an integral data type, which is also a simple data type. Notice how here it doesn't have to be assigned a value, versus here with a constant it must be initialized with the value immediately once it's declared. Here in the declaration it did not have to be initialized. And here I have a float. It should, there we go. We should use a double instead. All right, that's me being traditional. So here I assigned 2 to US miles, and in Britway I said is assigned the expression US miles times miles to kilometers, which is a mixed expression. US miles is an integral integer data type. Miles to kilometers is a, whoa, there we go, double, is a double. Okay, an implicit conversion will occur and result in a double. All right, because this is a double and this is an integer. So I'm going to see out, if you recall this, the number of miles from the cupboard to platform 9 3/4 is US miles, this variable, while the number of kilometers is Britway, and then there's my manipulator in L. See out, the number of miles from the cupboard to platform 9 3/4 is US miles, while the number of kilometers, and this time I take Britway, which is a double. Once it's evaluated, I then cast it to an integer. So this is an explicit conversion. All right, then you have system pause and return. Let's go ahead and run this. So you can see here, the number of miles from the cupboard to platform 9 3/4 is 2, while the number of kilometers is 3.21868, which is an implicit conversion, okay, which results in a double. When you have that mixed expression, basically the result will create the more accurate result. All right, if you truncated it, it'll be less accurate. That's an easy way of remembering it. However, in this very same case, I'm using the same variables. US miles, which is 2, but this time I casted it. So Britway, which we know before was 3.21, once I cast it to an integer, what happens is it takes that double value and then just simply truncates the decimals and turns it into an integer.